should be up.
There we go. All right. Well, welcome everyone to the Operate First Cloud Getting Started presentation. This is Operate First Cloud in its natural habitat. And this is to mostly serve as an overview of the Operate First Cloud and its initiative and what we do here and what it really means to do operations on the cloud. I am Humair Khan. I am a senior software engineer at Red Hat AI COE, part of the Office of the CTO. I work within the AI Ops division, and joining me today is
Tom. Hello, everybody. I'm Tom Coufal. I'm also a senior software engineer at Operate First. It's probably the same story as Humair. Compared to Humair, he's based in Toronto, Canada. I'm in Europe, in Brno. So we're covering all of the time zones now. So yeah, that's about the intro probably. Let's get started.
Cool. Thanks, Tom. So today's menu, we will be going over the Operate First initiative. I'm going to be kind of covering a little bit of recapping on Openshift. I know you guys have had some presentations on that already. Just make sure we're all on the same page. Then we're going to transition to GitOps. What is GitOps? Some key concepts there. Declarative management of Kubernetes and Openshift. Continuous deployment on the cloud via Argo CD. And Operate First community. So if you don't know what any of these things are, that's fine. Hopefully by the end of the presentation, you'll have a better idea. And if you don't, if you have lingering questions, you can always reach out to one of us to ask. Great. So starting with chapter 1, Operate First overview. So let's take a little bit of a side detour and just recap what are containers, Kubernetes, Openshift. And we're going to start from kind of like the baseline apps. So on the left here, you see there's a blue box, right? And this is to represent really any application, right? It can be a Python script. It can be a game server, like a Minecraft server. It can be a web server, right? And suppose that you wrote, let's stick with the web server example, right? Let's say you wrote this web server, okay? And you want to give it to me to run on my computer. And when I try to run it, it doesn't work. Why? Because maybe I'm missing some libraries, right? So let's say I download these libraries and it still doesn't work because my operating system is of a different version than yours, right? So you can see that these kind of problems can cascade really fast, especially if the application is very complex. So what you can do then is you can package your application in what's called a container. This is an OS level abstraction, right? It's virtualization, right? You can package everything that your application needs within this container. And then what you can do is you can give me what's called the container image, right? And I can run that container image in any Linux distribution, version, what have you, and it will run exactly the same, right? And this is a very powerful feature, as I'm sure you've already seen, okay? But it doesn't do everything, right? An application is more than the libraries that it uses. It's more than the operating system that upon which it runs on, right? An application needs space, right? If your web server has a database, right, it's going to need storage. It's going to want to talk to other applications. And that's where Kubernetes comes in. Right? Kubernetes at its core, regardless of how complex or whatever people might tell you, at its bare bones, what it does, it's managing containers, right? It is a container orchestration tool. It brings up containers, it brings down containers, it puts containers in different nodes or whatever, and they communicate, it allows them to communicate with each other or the outside world, right? And that is what makes Kubernetes really powerful. So where does OpenShift come in? Well, OpenShift is built on top of Kubernetes, right? OpenShift is described as the enterprise offering of Kubernetes because enterprises, big businesses, they have a lot of requirements, right? And OpenShift, what Red Hat decided to do is add all the stuff that they felt Kubernetes was missing, that the enterprise level was interested in, and they packaged that up and they distribute it as what's called OpenShift. So you can imagine it's just got like added security and all these other components that are listed down here. It's got added monitoring and so on and so forth, right? So at its core, what's really important here is Kubernetes. And in Operate First, what we do is we deploy what are called OpenShift clusters. We manage them. right? And if you look on this slide over here, we have operate first environments, which are the grouping of these OpenShift clusters. On the slide, I have what's in under the today section, under the tomorrow section. Today is what we have, well, today, right? And we have one environment, which is called the MOC environment, MOC standing for the Mass Open Cloud. What that means is not really important. What you need to know is that it is an environment which consists of different clusters, OpenShift clusters. And we have two clusters. One is called the infra cluster, and the other one is called the zero cluster. And what we hope to achieve, or what we're working towards in the future, is to have many environments like this that are composed of different clusters, right? So that if there's a user workload that wants to deploy to a cluster in this particular region, they would pick that environment that's best suited for their use case, right? So let's elaborate on some of the clusters that we do have, starting with the infra cluster. The infra cluster is, the heading here is the one cluster to rule them all, right? Thanks, Tom, for that. And it's essentially a management cluster, right? And what it does is it manages other clusters. It is very small in size, and it is very unlikely that you'll ever really work with it directly, right? Its entire purpose is to really house two essential applications or deployments, and one is called Argo CD, which we'll cover more on what it does later on in the presentation. And the other one is called ACM. Now, ACM, which stands for Advanced Cluster Management, is essentially just doing that. It's managing clusters, right? So the next cluster we have is called the zero cluster, and this is our workload cluster. It's larger in size. It has more nodes. It has more resources. And this is where all the user workloads go. So if you, for example, during an internship, need a OpenShift namespace, we could provision that for you on this cluster. And you can like deploy your own applications or that you're working on or what have you. And on top of that, we also deploy applications, and we call these managed deployments. One of which, or the bigger one, is called the Open Data Hub, which I think you've already seen a presentation on. And if you haven't, it's just a grouping, a collection of various data-driven technologies, one of which is Jupyter Hub, which you might come across, and we deploy that on the zero cluster, and other users can interface with it, and so on. Now, in this diagram is a bit more kind of a architectural diagram of what the clusters they're doing. And the blue boxes here, they represent the different clusters. So we have the infra cluster, we have the zero cluster, we also have a cluster X, which doesn't really exist, but it's to help better illustrate the point. And you can see that each cluster is housing different applications, right? These are the boxes within the blue boxes. And you can see on the zero cluster, we have app 1, we have app 2, in cluster X, we have 3 and 4. Then in the infra cluster, we have two applications called Argo CD ACM, which I already went over. But what's happening here is Argo CD. If you can see, there's an arrow that's going from Argo CD to app 3 in the cluster X, and there's one going to app 1. And it says it's deploying app 1 on this cluster, which is what Argo CD does, right? It deploys applications at destinations. And we'll go more into detail on how it does that and what that means, but just know that that's kind of what it's doing. Now, ACM is, instead of deploying the it's deploying the clusters, right? Like the arrow from ACM is going to the cluster itself, right? And same with the cluster X, right? It is actually deploying and managing these clusters. And if you want, we could bring them down using ACM. We can find more information about them and so on. Cool. So that's a kind of overview of the clusters themselves. And now we're going to talk about OpenShift and what it means to have or declare a declarative model for OpenShift and what that means. And we're going to do that through a demo. So I'm going to shift gears to the cluster itself. And we're going to be looking at the zero cluster, which is the larger cluster that I talked about. And when you first go to the cluster link, we'll provide all of that after the presentation. But you're greeted with this page, and this is just the login page, okay? And you can see that you can log in as kubeadmin, which nobody really ever does, or you can use the single sign-on. Here, I'm going to use the single sign-on, and anybody can log into this cluster if they have a Gmail account. You can use your Red Hat Gmail account, or you can use your personal Gmail account. It doesn't matter. What it does is it will automatically register you as a user, and you will be greeted once you log in with your Gmail account with this view, right? And this is called the developer view. And it basically gives you an overview of your applications and what you have deployed. And so within this project, right? So this is a Openshift project. If you look here at the top left, it says project opf/first. And this project, or an Openshift project, it's housing resources that are available to a particular set of users, right? One Openshift cluster is going to have many users, right? And how do you isolate what each user is doing? You do it via projects. You're going to have maybe have an Openshift project which you deploy your resources onto. Here we are deploying our Slack first bot, right? It's a Slack bot that we use for various different purposes in Slack, and it's a very minimal installation. Deployment, and you can see that there's only one deployment here, and I can move it around. And a more complex deployment, you probably have more nodes, and you could like fiddle around with all of the tabs here to get more insight into the application. But I don't really use this view that much. I don't find it particularly that useful. Some people do. But I like to use the administrator view. And when I click that, you see this kind of like already there's so much more information. And I'm a cluster administrator on this cluster. So I have access to a few more tabs than you might if you request access to this cluster. And it's giving me a lot of information. I'm not going to go through any of that today, but it's particularly useful to know what's happening, get a quick overview if there's anything wrong, so on. What I am interested in showing you is on the left, if I click the projects, I can see all the projects, right? And each project is generally tied to a particular team, right? And you can see that under the requesters. So we have like the data science team that has all these projects that are available to them that they can deploy resources to, what have you. And there's a B4Mad team created by our manager who deployed Minecraft on our cluster. And then there's the Slack first project, which I was showing you in the developer view, right? I can see that here, and I can click it, and I can see the overview for this project. Again, a lot of information to digest. Not going to go over it right now, but it's particularly useful when you want to see resource usage and all that neat stuff. What I want to see about this project, however, is where is this application? Where is this Slack bot? Right? Remember in the beginning, I showed you like we have apps, we have containers. Like where's all that stuff living? Well, it lives as a pod, right? So containers, they exist in OpenShift, but you never deploy a container. Container doesn't exist as an abstraction. What exists is a pod, and a pod contains containers, right? So this is one pod, right? And this pod contains the container, the Slack first, and this is our application, right? And sure, I could create a pod here in this UI, but typically you also don't create pods. You create what are called deployments, which then are responsible for pod creation or definitions. Right. And so you can see this kind of like a hierarchy that's starting here. Like you got containers that are in pods that are part of deployments, and so on. Right. So if I look at deployments on the left here, I can see that this is the deployment that is deploying the pod that I saw within the pod section. And I can see here under status, it says 1 of 1 pods. When I click the deployments, I get more information about that deployment. I can see that, again, there's one pod, which basically means there's one instance, one replica of this application that's running, right? Why is this important? Why would I want more? Well, if you imagine, for example, if you have a front end for a web server, you can have multiple pods that are handling multiple traffic, right? So you don't get bottlenecked upon one application. I could change this the number of pods here by clicking this up arrow. Super easy, right? But what's important to remember is all of this information, like how does this look behind the scenes, right? We're interested in that. When I pressed up, what is really happening is in the background, Openshift is submitting a REST call telling the Openshift API server, like, okay, I want 2 replicas, right? And what it's doing is, if you look at the logical representation of how Openshift sees all of this resource, it's all in a YAML file, similar to a JSON file, right? That is the logical representation of all of this data. And if I see over here the tab that says YAML, I can see that YAML representation of this deployment resource. Now, this is really important because this describes exactly what this deployment is. Everything that's relevant from Openshift's perspective can be seen here. Remember when I changed the replicas to 2, that was reflected in this manifest. In fact, I can change this to 3 and it would reflect that in the console UI, right? You can also see other information here. For example, you can see the name of this resource, Slack first, right? That's the name here. This is getting it from the manifest description of this resource. So let's try changing the resource and see what that does, right? So if I go back to deployments and click, I can see that in this Slack first deployment, this is now being scaled to 3. I did the same thing. The actions are identical. I pressed up or I changed the YAML manifest because behind the scenes, a REST call is being submitted with this manifest description of this YAML, and the end result ends up being the same. Now, what's important is that this is just an editor, right? Like this is a file. This is a YAML file. This is an editor. When I click save, this file is sent to the Openshift server. I can do this through the UI, but it doesn't have to be from the UI, right? Like I can actually do this through my console. And here I have a terminal. I'm logged into the cluster, right? So if I type project, I can see that I'm in this OPF Slack first project. If I go back, I can see the project is OPF Slack first. I can get all the deployments, and this might take a little bit longer the first time it pings the server. But what I'm doing here is I'm getting the list of deployments, which is akin to when I click deployments here and I ask for a list of deployments and I expect to see Slack first, right? And lo and behold, that I see the list of deployments. Here we only have 1, and I can see that this is the deployment that we were looking at in the UI. I can get more information about this deployment by typing OC describe deployment Slack first, right? And it gives me all of this information that I can also see if I click here, right? This is the similar information both the UI and the CLI command are doing the same thing. They're reaching for the same endpoint. So can I then get the same YAML like I can from the UI from the CLI? I can, right? I can do OC get deployment Slack first, and I can do a -O for output and ask for the YAML, and it gives me the YAML. In fact, I can edit that YAML directly, right? I can do an OC edit deployment, and then I can type Slack first, and it opens an editor, much like how I did it here, right? I have an editor, and if I look for replicas, I can find that, where are they? Like this replica, I changed it to 3. I can change it here and save it, and then Openshift will, or the command line tool will send this manifest to Openshift asking it to change the replica again. But what I can also do is I can get this YAML, I can save this YAML. So let's save it, like redirect it back to my local directory, which I have up here in my IDE, right? I can open this file, and I can see that exact same YAML, except this time it is not on Openshift, right? It is on my local directory, right? I have essentially copied the state of this deployment and put it on my local file system. And I can change it to, let's say, 2 replicas. Okay, now obviously nothing's happening yet because I haven't really submitted this back to Openshift. It's still at 3, right? But right now I'm saying that, you know what, this is what I want to happen. I want I want the number of replicas to be 2. So what I can do is I can I can use the CLI and tell that, okay, you know what, take this file and apply it. OC apply-f deployment.yaml. When I do that, right, it says deployment / first configured. And look, it's back down to 2, right? So this is critical, okay, because what I have essentially done is I've said that, you know what, this is the deployment I want on Openshift, and make it happen, and Openshift makes it happen. And now what's in Openshift is the same as the file that I have here, right? And this is going to become relevant later on, but it's important to remember that I did this for a deployment, okay? In Openshift, most resources can be defined as YAML files, right? So I did this for deployments. If I go to pods, and now we have 2 pods because we changed it, but if I click the pod, I'll see that there's a YAML, right? There's a definition of this pod that exists in Openshift, which Openshift is using to give us all that information back in this kind of like pretty format, right? And this is true for any other resource. If I go to config maps and I click this config map, I'll see there's a YAML for the config map, right? And this is not just true for resources in your project. This is literally true for most resources in the cluster, including the resources that make up the cluster, right? So in essence, I can have not just the deployment, I can have the services or the project, the project itself, like I showed you, all of this stuff, I could have it in my local directory. And then if I want, like maybe I want Tom to see it, I can send it to Tom. Maybe I can put it up online, right, on a GitHub repository and show it to the world that way. Like, oh, this is what my deployment looks like. And this will transition into what we call GitOps, which Tom is going to show you, cover for you. But before we do that, the one last thing I want to leave you with is if you want to try any of this stuff out, I highly encourage you to do so. It's very accessible. You can get your own OpenShift instance. In this slide, I think we sent this slide out, but if we don't, Tom, I think, can link these links for you in the chat. But if I go to this link, for example, learn.openshift.com/playgrounds, right, I can see that it gives me these options to create my own OpenShift playground. And if I click Start Scenario, it's going to spin up an OpenShift playground for me, and it can do one for you. It's relatively quick. It lets you play around with it, mess around with it, delete whatever you want, add whatever you want. You can try everything I've shown you here. In that environment, you'll have cluster admin. It's a really good learning experience. And if you go back to the homepage for learn.openshift.com, you're going to see a lot of other different scenarios that are also equally as helpful and to help you with your learning and getting quickly acquainted and ramped up with this stuff. So that's it for me. I'm going to pass it over to Tom, who's going to cover chapter 3.
That was a lot to digest. Okay, I'm gonna steal your screen share. Can you stop sharing now?
Yes. There we go.
Awesome. Can you see my screen now?
Yep.
Great. So Humair covered OpenShift as a declarative manifest. That we have something called YAML files or YAML resources that are working behind the scenes in OpenShift, and it is the representation of any resource in OpenShift. And I'm repeating this because it's crucial for understanding how Operate First behaves and how declarative management of any cloud native resource actually happens. So we manage those resources in kind of a GitOps way. What does it mean? What does GitOps stand for? Again, buzzword shortcut, pretty nice one. It rolls on tongue pretty nicely. It means that we're doing operations, which translates to managing and taking care of stuff, in this sense, applications in OpenShift. And we do this via Git, via version control. So the key concepts here to understand are 3 basic ones. Applications are viewed as a code. Application is no more some fancy configuration scripts and lengthy documents where you tell users where to click and what to do step by step, how to spin up an application. Instead, you have explicit declarative manifests, these YAML manifests, and you store them as a code, and you enable other users to share those manifests and such. You do this via version control. That means in a Git repository allows you to share those data, share those manifests, similar to any code to any application. It allows you to have a single source of truth, well-defined, again, explicit, and also distributed and versioned. So each of us in the team and anywhere in the world can have their own copy of this repository, can view those manifests, can do changes to those manifests declaratively, locally. And if they want to share those changes or apply those changes in a shared environment, they submit the changes as a pull request that can get reviewed and then merged into our main repository that we basically mirror to a live environment. So I think you can sense some kind of a flow in there. I do changes locally, I submit those changes, the changes lands on a Git repository, changes are picked up and are applied to a live environment. Again, I take the YAML file and basically do the OC apply command that Humair showed you before. Now, let's take one step back to the YAMLs and definitions of the resource on cluster. This was the view that you saw on the Openshift console UI, right? Kind, deployment, API version, some metadata, bunch of different stuff. It's a declarative, complex representation, holistic view of that particular resource with every tiny bit that belongs to the resource. We want to track that, but we also want to make this resource manifest portable. We want to be able to share this. So sometimes you don't care about specific sections of the manifest. For example, I don't care about which generation this manifest is, or what is the creation timestamp, or what is the UID, which is the internal representation of this entity within the cluster. I usually don't care about many of these aspects. I don't care about the current status, for example, and various different things. I can also introduce changes in here. So that kind of gives you the incentive that application state and this YAML file can exist in different versions, in different states. That I have a state that is live on the cluster. I have a state that is desired and required and tracked in our Git repositories. And there is, for example, another state that is like the internal representation of most of the other things that I may not care about. So in GitOps, we differentiate two most important states of an application manifest. I have a state on cluster, live state, cluster state, however you call it. And this is what is actually deployed and living on the cluster and is accessible to users and is doing the work for you on the cluster. Then there is the desired state, the changes, the manifest description that you have in your Git repository or on your local machines. This represents all the changes that you may want to happen to this resource in the future, right now, or in the past, how you expect this resource to look like. And these states don't need to match all the time. I may, as Humair did, do changes manually to the cluster. Right now, if I do those changes manually, as Humair did, the application will no longer match my desired state that I have in our Git repositories, for example. Or if I do changes and submit a PR, the PR gets accepted, the desired state changed, and it needs to be applied to the cluster to propagate to the live deployment. So the cluster state would match the desired state. And again, we're here working in a never-ending, endless loop of adjustments. We have a desired state. We apply these changes or this desired state to a cluster. We match it with the cluster state. We observe what's going on with the environment. And if we want it to behave differently, we take some action, change the desired manifest, the desired state, apply those changes, propagate it to a cluster state, and observe again. If the resource misbehaves and changes the manifest itself, for example, for some unknown reason to us, we observe it and we take corrective action for that cluster state that it's not matching our intentions, it's not doing what we want. So again, we apply changes, we would take our desired state, apply it to the cluster, and again, make the cluster match our desired state. And again, endless loop. So how to make our life easier with this? As you saw in this picture, there's a lot of manual steps in here. Applying changes, observing those discrepancies, taking actions, taking corrective actions, doing changes to desired state. How can we make our lives easier? We have something called Argo CD. There are various other systems that can do similar stuff. It's a continuous delivery tool that basically does some of these things for you. We chose Argo CD because it's a cloud native and it's very well suited for GitOps principles. What it offers us is that it's an application, piece of software that is watching for those changes instead of us, and it applies those changes instead of us. So it basically tries to ensure that our desired state in a Git repository is matching with the live state on cluster. It can correct behavior, correct discrepancies if the manifests are changing itself. It can allow you to do auditing in a way that we have some changes happening on the manifest. We can see who did those changes. We can see that those changes were not good for the application. So we can, for example, roll back to a previous state of the application. So now with Argo CD, we replaced half of these steps, or nearly all the manual steps with Argo CD. The only thing that's basically left is to take the action and decide what we should do with our application next. And we need to figure that out ourselves. So we change, if we decided that we need to change those desired state, desired manifests, we do those manually via pull request in GitOps. So, and again, we're at a phase where we should do a live demo because slides may lie, and if I show you live demos, it won't work, or it won't lie. So we have this Argo CD instance here. It's running on our clusters, on the infra cluster, as Humair mentioned before. It looks like this. I can log into it via Openshift, same as you would to the console. And yeah, this is my slow network today. I don't know. Will it work? Won't it work? Okay, let it load, and let's take a look here first. So we have this manifest tab. We have we have the same in the console as Humair showed you. And we get the same manifest, same incentive in Argo CD if it loads. Humair, you may need to jump in here because Argo CD is kind of...
You want me to show it for you?
Yeah, probably.
Okay, I'll share my screen.
Still working for me.
Okay, I'm sharing my screen. Do you see it?
Not yet. Oh, yeah, I do.
Cool. So logging in.
Okay. Well, I got logged in, so
yeah, feel free to take over. If you,
yeah, I'm gonna take over.
Okay.
Sorry, guys, for this. It seems like Kirsten is right. It's my DNS for some reason. So we have this view of Argo CD. Complex UI, completely different to the Openshift console. Don't worry about it that much. Each of these squares, each of these tiles in here represents an application in Argo CD sense. Application basically means encapsulation of all those resources that we would like to be isolated into a namespace, into a project. Maybe your internship project is one application. For example, the Slack bot is an application. So let me share for it. Here we have a OPF Slack first application, which looks like this. Huh. Does it? That doesn't sound like DNS. Okay, this doesn't work. Humair.
All right.
I can't do it.
I'm here for you, buddy. Don't worry.
Good. So this is how the Slack first application looks in Argo CD. You see, we're deploying some of these resources, few of these resources. And if we go to the app details on, yes, here, we have some information about the application. So we are telling Argo CD to deploy into a certain project, into a certain namespace, and to deploy from a Git repository, from a certain branch, and from a certain path within the repository. This is where we store manifest for this particular application. So if we go back to the resources overview, we have most of the applications in green state, green hearts, green check marks, all nice. One of them is out of sync, is kind of yellow, and in the current sync status, we see also out of sync label. Here we have 3 tabs: live manifest, desired manifest. So live manifest is what is actually live on the cluster. That was the cluster state of the application. Then that has the replicas too, as Humair is highlighting right now. Then we have the desired manifest, which is what we want it to be, what we have. And as you can see, it's a very stripped down version of the manifest. So if Humair switches back to the live manifest, we don't have any of these annotations. We don't have any creation timestamp, no generations, nothing like that, no managed fields, for example. We don't care about those. Our desired state is specifically interested in those fields in the manifest. So we're interested in spec replicas to be 1. We don't care about managed labels, for example. So if we take a look at the diff, that's the difference between those manifests, between the live one and the and the desired one. We can see that Argo CD is telling us, yes, we have a difference in replicas. Yes, the source and the desired manifest comes from the Git repository, and Argo CD is listening for changes in the Git repository and basically allows us to automatically propagate those changes once we merge a PR to a live deployment. So what we can do now is we can force the desired state to, or the cluster state to match the desired state. Normally, we would have autosync enabled on this application, which means whenever this app gets out of state, out of sync, Argo CD will go and correct it, force it to be in sync with the desired manifests. So what we can do now, we can do sync manually because we have disabled it. So we have a sync button here. We can see which kind of resources are out of sync, which are not, and we can make Argo CD to do the OC apply for us. And again, if we have auto sync enabled, our Argo CD will come, would do it anytime it observes any changes in the environment. So right now it's syncing, and in a couple of seconds, it should sync the application. Now it's green. It's all nice. And if we go to the Openshift console right now, we can see that the deployment is scaled back to 1 pod. So Argo CD went and really did changes to the manifest on the cluster, submitted the YAML for us. So this is nice GitOps flow for any normal application, right? We're working with deployments, we're working with pods, we're working with containers, and we're scaling applications up and down and doing various changes to it. So there's also the thing that Humair mentioned. We can do the same with clusters, with cluster resources. So, for example, Humair showed you the list of projects in this console. And we have many different projects here. We have also the Slack first project in this list, which basically corresponds to a namespace in Kubernetes way, in Kubernetes world. In OpenShift, you have also a project resource, but there's one-to-one mapping. So there are various different projects. So if we go and take a look at the Argo CD, we have also applications for managing those cluster resources and managing those cluster-wide important things that makes up the cluster and enables people to work with the cluster, creating namespaces, creating user groups, creating networks on the cluster, and stuff like that. So if we take a look at this particular application, this is cluster resources for the zero cluster. We can focus just on the namespaces. And again, if Humair searches for the Slack first, we have a namespace resource that we're deploying through Argo CD, and Argo CD will go to our repository, take the manifests, renders it, understands that it should deploy this particular manifest, this particular namespace into our cluster. So if you take a look into the cluster, into the namespace resource in the cluster state, live manifest, this is what we have deployed on the cluster. Again, YAML resource with some metadata, with some specification. This makes up the namespace on the cluster. Similarly, we can do it for everything. We can do it for the applications itself in Argo CD. So we have declarative manifests for Argo CD applications, because Argo CD application is a Kubernetes resource. Again, the same story all over again. So we have this app of apps 0. Yes, this, okay. We have this manifest basically that represents this particular application. It goes to this repository, this path, and this is the destination. This is what Argo CD understands and acts upon it. So we have applications that track those application manifests. And we have, yes, it's auto-synced up there. Great. So we have this live manifest, this desired manifest, and again, we disabled for this demo, we disabled the auto-sync on this application, and Argo CD knows it. Argo CD is telling us, hey, this application based on your desired state should have auto-sync enabled, should have this portion of the manifest applied to your cluster. That means, that translates, Argo CD knows about this change, wants to apply it, and if we have auto-sync enabled here, it would just go and apply it and do those changes for us. Same story again and again. Desired state is different from cluster state, from live state. Hey, let's change it. Let's apply those changes. So let's change it. Let's sync it. And again, we're syncing this particular resource, and it should turn green in a minute. Apply those changes on the cluster, and this application will be auto-synced for any changes in the future. If we change anything in the Git right now, if we merge commit anywhere, this would propagate here automatically, and the application will propagate, will accept those changes on the cluster. So let's take a look at how these manifests are actually structured in the repository. If you click the repo URL, great. We have this repository that tracks manifests. So if you scroll down into the Slack first folder, into base, into deployment, yes. Here is the YAML representation of this particle deployment that matches what we want to have on the cluster. It has one replica. That's what we want. That's why Argo CD was complaining that our live state does not match. So that kind of concludes this demo. And let me jump back to the slide. Humair, you can stay screen sharing. Maybe it's easier right now. So this is a very stripped down and simple version of GitOps that we use in Operate First. We use automation for most of the part, and we track our applications in various repositories. So on the next slide, you can see that we structured our manifest or our repositories in a certain way, that we have apps repository for all these manifests that we host and manage, including the cluster setups, including Open Data Hub, and other various applications that we care of. Then we have Argo CD apps repository, where we track all these application manifests for Argo CD, because those are kind of special for us. Those are defining how Argo CD should behave and manage clusters for us. We also have Blueprints repository, where we track our journey, how we decided on various aspects of it. So maybe that's also an interesting read for you to understand how we approach certain areas. We also do SRE and incident management, and we define some processes, how we should approach outages, how we should approach various incidents in the GitOps fashion and in timely fashion. So those live For example, in the SRE, in alerts, we stream all those alerts that OpenShift generates for any application, any cluster resource into a GitHub repository. So those are publicly available as well and linkable into issues. Let's go to the next slide. So Operate First as a community offers various ways to interact. You can directly go to the clusters and do changes. You don't need to use GitOps principles to work with OpenShift clusters. You can just log in into the console, tell us, give me a namespace. We will create a namespace for you in our GitOps scenarios. So it's repeatable, recreatable whenever the cluster goes down or not. And you can work with the cluster, or you can try out these GitOps things and fancy stuff as well. And you can submit a pull request and do those changes declaratively, which kind of also allows you to replicate the setup anywhere else than on our clusters, because those manifests are declarative and transferable and shareable. So we have this support repository where you can ask questions, you can get user support, you can request onboarding and various cluster scoped resources like install this operator for me, please, or whatnot. You can also go and reach out to us on Operate First Slack, which is our go-to platform for chat, where we discuss all things related to Operate First, where we track outages, resolve incidents, and you can just pop in and take part in any of those discussions. We're open to collaborations on any aspects of managing clusters. We have also this website here, which includes all our decision records, documentations, guides for ODH, Open Data Hub, and other aspects and other workloads we deploy on top of Operate First Cloud. And next slide. We have also some valuable links that we used throughout this presentation. So if you want to go to directly to the Argo CD, you can go via this link. You can access the UI console for the Zero cluster right here as well, and get to our GitHub organization, for example. So before we end this, are there any questions?
There might be a couple of questions in chat.
Okay. Can anybody tell me what a replica is? Type down in chat what do you think a replica is. Okay, maybe not.
It's been a long day.
It's been a long day. I know, there's been a lot to digest, I know.
There you go.
Scaled pod, yes. It's an identical copy of a pod, basically, based on the deployment description. You can have multiple identical copies. So do you know, after this presentation, what a desired state is? Or were we totally incomprehensible? Okay, it's not a test.
I had no idea he was going to test you guys after this. This is totally him.
It's not a test. I'm just trying to like get an information, like a feedback, if like any of it that we told you was any use for you. I hope it was.
That's correct. It's a place applications should be. It's where we define how the application should be in Git. Yeah. It doesn't have to be Git, but in GitOps, it's in Git.
Yes, it can be any version control. It can be plain files. It can be whatever it can be. Yeah.
just remember everything is a YAML. And if you have like any questions, definitely reach out to us. The Slack that Tom linked is open to the public. So that's another thing to mention, is that the stuff that we do is not Red Hat internal. The idea is to make it open. So even like your friends, whatever, like these guys can come on and like read and check out the stuff. Yeah, like the Minecraft server I showed you guys, it's literally like our manager whose kids are playing on it. So where anybody can join the Slack, ask questions. There's a support section. We have docs, and if you're, so we're there.
And if you want to quickly access the Slack, we have invitation linked in the website. So just open this website, operatefirst.cloud, top right corner, join our Slack, and say your highs or no, say nothing. Join us. We're open to collaboration on any level of the cluster management. So if you want to get your hands dirty with managing clusters and understand how is actually OpenShift structured and what does make OpenShift happen, we're also open to share this knowledge with you, teach you how to do it, let you get your hands dirty, let you touch the clusters. So come and join us.
All right, thanks guys.
Awesome.
Thank you very much.
Thank you, Tom. Thank you, Humair. Before we leave, so Tom and Humair, where do you think would be the best place for them to reach out if they want to onboard themselves? Do you think the website should be sufficient, or do you guys have any other pointers for them to reach out to?
We encourage people to either ask in support Slack or make an issue in the support repo. So these are so the support repo is the GitHub repo. That's the first kind of stop where if you need anything and you're not sure if you're asking the right place, you can ask there, and we will either redirect the issue if we need to, or we'll just respond there. And yes, there's also Slack. So we have people asking questions there all the time.
Awesome. Thank you. Thank you, folks, for joining in. And once again, if you have any more questions related to Operate First, we have everything up on the website. But again, if there's something missing, we always encourage you guys to reach out to us. We're trying to constantly keep this as self-guided as possible. So please do let us know if there's something missing out there, and we would be happy to add that missing guide or documentation. So thanks again, Humair, Tom.
Thank you very much for listening to us for over an hour.
Thanks, guys. Bye.
Thank you very much.